Okay, welcome guys to the Intro to TinkerCAD workshop hosted by the IEEE UTD Tech Committee. First off, we're going to start with sign-ins. So just scan the QR code or add the link below the QR code to sign in so we know that you guys showed up. And for those who are going to join later on, um, we'll most likely post the link in the chat for those who get here later. So I'll leave this up for a few minutes so y'all can sign in, and we'll get started soon. All right, I think we're gonna get started now. So the basics of TinkerCAD. TinkerCAD is an online simulation tool for 3D modeling, circuit design, and coding. They offer free lesson plans, and the main one we're going to use are circuit design and coding. So with circuit design, it has a bunch of components that include Arduino, sensors, motors, logic gates, and a lot more. And there's a coding section in the circuit design which lets you code and simulate all in the same place. And the best part about this is that it's completely free, it's really versatile, and it's convenient. I'm going to ask y'all to create a TinkerCAD account if y'all haven't done that. And how you do that is you just go to tinkercad.com, click join now in the top right corner, click on your own personal account, sign in with whatever email you want to use. And once you've signed in, you go to the left column, click circuits, and create a new circuit. I'm going to do the last two with y'all, or the last three. Um, but I'll wait here for a couple minutes for y'all to do that. Oh, my bad. I'll go back to the sign-in sheet. Alan's trolling me out here. All right. So I'll give you another minute to create your TinkerCAD accounts. I'm going to start giving y'all some brief information about Arduino. So basically what an Arduino is, it's like a credit card sized computer. Like it has a lot of computational power and you can do a lot of things with it. It's very versatile. Um, its power is very good. And the best part about it is it's really low price and it's easily manufacturable. And there's a ton of people who use it. There's hobbyists, makers, artists, but most importantly, students and mainly engineering students like us. We use this a lot for personal projects and all of that. Today, we're going to be learning how to use a temperature sensor and a gas sensor. So how a temperature sensor works, it detects changes in the temperature in a given area by um, so it reads the change in temperature, and from the change in temperature, it varies in resistance inside of the sensor, and the change in resistance outputs a voltage value to the Arduino. So that's how it works. And it's important how to use this because we can know the freezing point and the melting point of a bunch of elements. And a main example in our case would be the temperature sensor can let us know if there's a certain part of the circuit that's overheating or not heating up as much as it should. Um, and if an important IC chip is actually reaching a dangerously high temperature, that's not very good. We don't ever want that to happen. So that's an example of how a temperature sensor could be used. A gas sensor, it detects different types of gases within an environment. A few are methane, carbon monoxide, ethanol, and there's more. So the detection is based upon a change in resistance of the sensing material when the gas comes in contact with the material inside of inside of the sensor. The gas sensors are important because they can detect concentrations of certain gases as well as to check if they're toxic. So how you could use this is, let's say you turn your kitchen stove on and it's gas powered, but you didn't turn it off completely all the way. If you have like a little circuit and the gas sensor and you program it, you could have a buzzer wired up to it and it can make a noise if there's too much methane or butane coming out of your stove because you didn't realize if you turned it out. So that's an application you could use. And I want to thank y'all for joining and please sign in if y'all haven't already. Now we're going to get started with TinkerCAD. So we're going to head over to tinkercad.com and you're going to click on your profile, which will take you over here. You're going to click on circuits and we're going to create a new circuit. So the components we're going to be using today are the gas sensor and the temperature sensor, specifically the TMP36. Some other components we're going to need are the Arduino Uno R3 and a breadboard. So the wiring for both of these sensors are fairly straightforward. Um, but first off, I want to give y'all some information about how the breadboard works. We use breadboards mainly to wire components together, and um, the columns A, B, C, D, E, they're wired together horizontally, and F, G, H, I are connected together right here, so you can see it. So these two are separate from each other, but these five are wired together. So A through E are wired together, and F through J are wired together. And these positive and negative signs on the sides indicate for voltage and ground, and they're connected vertically next to each other. So that's what you'd mainly use those for. Um, I want to start off with hooking up our voltage. We're going to be using 5 volts today for what we're using. And I'm going to wire it up to the positive, and then I'm going to connect ground to the negative on the breadboard. And I'm going to make the 5 volts red and ground black. And a normal thing to do is once you connect um, power and ground on the side, you can connect the other side of power and ground of the breadboard. So I'm just going to connect power over here and make it red also, and then connect ground as well, which I'm going to make black. So now that that's done, I'm going to start off with the temperature sensor. The wiring for the temperature sensor is very straightforward. So how it works is you have 3 pins. You have power, your V out pin, and ground. So yeah, what's up? Um, I mean, there's not much I could do about it. Like the Wi-Fi I'm using right now is the best one I have around. Yeah, unfortunately, no. Do you want me to slow down for a little then? All right. Oh, sorry. I accidentally reloaded the website, so I have to wait for the project to load again. All right. So I'm gonna continue. So there's 3 pins for the temperature sensor. I'll try to go a little slow since there's apparently a little buffer with me streaming. But the three pins are the leftmost is power, the middle one is V out, and the right side is ground. So what we're gonna do is wire it exactly like that. So I'm going to connect power to the leftmost pin, and I'm going to make it red, and I'm going to connect ground to the rightmost pin and make that black. And I'm also going to connect the analog pin 0 over to the middle pin for this. And I'm just gonna make that blue. I'll wait a second because of the buffer, let y'all see how it's wired and let y'all do it. And then I'll start writing the code for this and I can demo it for y'all. Alright, so I'm gonna get started on the code now. And we're gonna be coding in text, so um, you're gonna change from blocks over to text. And I'm gonna start off with declaring some variables. So these are the variables I I'll be using for the temperature sensor. So the variables we're going to be using are float Celsius, float Fahrenheit, float voltage, and float sensor value, as well as int temperature sensor pin, and we're going to let that equal to analog pin 0, and that's just the easy way and making the code readable whenever um, we code along the way. So what we're going to use these variables for is Celsius, it's going to hold the temperature in degrees Celsius. Then Fahrenheit, we are holding the temperature in degrees Fahrenheit. Voltage, so how the temperature sensor works is it doesn't give you the outright exact temperature, you have to calculate it. So it gives you a voltage value and it tells the Arduino what that value is. And we have to manipulate that value so we can get it in degrees Celsius. So that's what we're going to be using voltage for. And the sensor value is what we're going to use to hold the value that we get from the temperature sensor. So what we're going to do now is we are going to tell the microcontroller that the temperature sensor pin, which is analog 0, is an input. So we're telling it that we're going to be receiving data from it. And we will do the serial.begin 9600 so we can use the serial monitor. So now I'm going to be writing the code for how to get the exact temperature. So first we have to collect the data from the temperature sensor, and how we do that is we're going to store that value in sensor value, and we get the data using the analog read function, and we're reading from the temperature sensor pin. So this is just collecting the data from the sensor. After that, we have to calculate the voltage. from the temperature sensor. And how we do that is it's just the voltage is the sensor value multiplied by 5 because we're powering the temperature sensor with 5 volts. So we multiply by 5 volts and then we divide the voltage by 1024. And that gives you the voltage from the temperature sensor. After we do that, we can go straight into calculate the temperature, and we're going to start with degrees Celsius. So now we're going to be storing or calculating the value of Celsius first. And we do that using the voltage that we got. So now to calculate the temperature in Celsius, it's just voltage minus 0.5, which is an offset of 500 millivolts, and we multiply that by 100. After we calculate the temperature in Celsius, we have to calculate the temperature in Fahrenheit. And that you just use the simple formula you learned in chemistry probably in high school, which is 9/5. I'm going to use 9.50 because if you do 9 divided by 5, it'll be integer division, which is C and C++ stuff. So instead of, if you do 9 divided by 5 just as integers, you'll get 1 instead of 1.8. So that's why I have to do 9.0 divided by 5 specifically. And then you multiply by Celsius and add 32. After that, we have both the temperature in degrees Celsius and degrees Fahrenheit. And all we have to do now is print the temperatures to the serial monitor. And how we do that is we use the serial.print function, and you can print strings and any values that you have stored in variables using this. So I'm going to print Celsius, the string Celsius colon space. And after that, I'm going to use the serial.println, which means it's going to print whatever you put in the parentheses, and after that, it's going to create a new line. It's just a formatting thing. So now I'm going to print the value I have stored in Celsius. Then I'll use serial print again to print the temperature in Fahrenheit. And then I'm also just going to add a new line just for formatting later on. So now I'm going to demo this for you. So I'm going to start the simulation. I'm going to open up the serial monitor too. Right now it's saying the temperature is just 24 degrees Celsius, or almost 25. And that's very accurate because right now it says it's sitting at 25 degrees Celsius. It's really hard to read, but that's what it says. And as I change it, you're going to see the values should change as well. And the maximum is at 125 degrees Celsius. And you can see that we get 124.8, which is very close. And the minimum it'll be at is negative 40 degrees Celsius. And you can see that as well. So that's just how you can set up your temperature sensor. Very easy, not very complex. And now I am going to do the gas sensor as well. So the gas sensor, it has a few more wires to it, but it's not very complex either. So how you wire the gas sensor is these bottom three pins, you just wire them to power. And I'm going to make these wires red. So now it is powered.